Okay, so 6.4 is going to be about arithmetic sequences. Arithmetic sequences are just sequences where the difference between two consecutive terms, so between these two terms, any two consecutive terms, it's constant. So as you move from first term to second term to third term to fourth term, the difference is d. You add a d every single time, d, 2d, 3d, and you can say you're multiplying it or you're adding another one. Okay, and the formula for that is going to be this right here. T of n, so the term at whatever number is going to be a, which is the first value. Okay, let me write that down. And you can see that in the term right up here, right? The first value is a. And d is the common difference. Okay, something special about arithmetic sequences is we're always talking about addition and subtraction as the common difference, right? It's called a difference because that's the subtraction between two numbers. Okay, so that's how we know it's arithmetic. Okay, so first question is determine the values of the first term a and common difference d for each arithmetic sequence. As easy as possible when you're given actual terms, like the first term is a. So I mean over here, not much to do. A is -4. I mean, you know over here. A is 1/3. Okay? Not so obvious over here. For A, we have to plug something in to get it, but that's no problem either, right? T1 equals 2 times 1 plus 3. So T1, or A, is 5. Okay? And we can say A is 5 because that's what the question is actually asking. And I'll box these. Okay, for the common difference, all you have to do is subtract two terms. As soon as you know that it's arithmetic, if you subtract two terms, you'll know what the value for the common difference is. So if I subtract this by this, 0 minus -4, I'll do it down here, 0 minus -4 is equal to 4. So the difference is 4. This has to be true for all of them. 8 minus 4 is 4, 4 minus 0 is 4, 0 minus -4 is 4. Okay, that's what tells you that it's actually an arithmetic sequence because there's a common difference and it's constant. Okay, over here we got fractions. I have to do 5/6 minus 2/6. I'm going to convert that 1/3 into common denominator right away. And I'm going to get 3/6. So the difference is 1/2. Okay, to find the difference, the common difference in this question, I'm probably going to have to find T2. Because once I find T2, I can subtract T1 and I'll know my common difference. So T2 is 2 times 2 plus 3. T2 is 7. I don't have to box that. So my common difference is going to be 7 minus 5. And the difference is going to be 2. Okay, A and D, super important to find. You can plug them into your formula and simplify this once you plug this in, right? So I can multiply n times d and -1 times d to simplify that once I have values. Okay, moving on to a word problem. Charlie paid $5,000 for an antique guitar. The guitar appreciates in value by $160 every year. If he sells the guitar for $7,000, how long has he owned it? If you were honestly 12 or 13 years old, you could probably do this question just by trial and error. It's a pretty standard linear question. The important part about 6.4 is you need to learn how to do it using the formulas for arithmetic sequences and the knowledge for arithmetic sequences. So, what do we know in this question? We know, do a little note, since the value increases by 160 every year, we know that this is arithmetic. And that's going to be one of the struggles in chapter 6. It's going to be the difference between arithmetic and the next section, which is geometric. You have to know the difference because they have different formulas. Okay, so because we're adding 160, we know that it's arithmetic. Okay, next, we want to find the A value. Okay, the A value is going to be after 1 year. Remember that car question from yesterday? It's not the 5,000 because that's the 0th term. We don't want the 0th term. The A value is the first term, and this is going to be 5160 after 1 year. Okay, or we can say T1 is 5160. Okay, so now we have A. All we need is D. And D, you can just read it from the question, it's going up by 160. You don't have to put the dollar sign every single year. So my formula, do it here, just copy down the formula. Every time I have a new formula, I always copy down the actual formula because it helps me memorize it. And now I plug in the things that I know. I know A. I don't know N, I'm solving for N, and I know D. Okay, something tricky when you're dealing with questions in this chapter is the final term. Even though I don't know how many terms there are, if I imagine that there are N terms, T at N is the final term in that sequence. Therefore, if the final term in the sequence is 7,000, T at N is actually 7,000. Sorry, I forgot a plus sign here. Okay, so here's your first challenge of understanding. Everything's been pretty easy so far. T at N is 7,000. Okay, now I can just solve for N here. I can move the 5160 over. So I should get 7,000 minus 5160 divided by 160 equals N minus 1. And this should give me 12.5 equals N. Okay, I have to add the 1 at the end as well. Okay, plug it into your calculator, done. It's a word problem, so I'm going to end it with a therefore statement. Read that last sentence. If he sells the guitar for 7,000, how long has he owned it? He has owned the guitar for, should we say 12.5? I guess we can. No, we shouldn't. 12 or 13?
13.
But he has it only for 13 years.
12 and a half.
I know, I'm going to keep it at 12 and a half.
To say 12 and a
But in
half.
terms of a natural number, it should just be a 12.
150 years.
More than 12 years. I can say that. Okay, next one. In the arithmetic sequence, T11 is 72 and T21 is 142. Very common question. I wouldn't say it's as hard as it gets, but it probably is as hard as it gets for 6.4. And this is a grade 9 question, right? This is find the equation of a line using 2 points. Find slope, y-intercept. It's just a different way of thinking about it. This is a point with x11, y 72. This is a point, x is 21, y is 142. It's the same thing. Okay, so to do a question like this, stay in purple, sure. Okay, I'm gonna write down my formula. Okay, until I'm sure about my formula, I write down every single question. It also helps me build confidence on what formula to use. Okay, so for T11, I know that 72 is T at N, and this is equal to the A value plus 10D. Now how do I get that? How do I know that 10 is next to D here?
Because it's turn 11 and it's 1.
Yeah, so if I wanted to do a step before this, which I should and will, I'm actually going to do A plus 11 minus 1D. So 72 equals A plus 10D. Okay, pretty simple. For the other one, term 21, I'm going to have 142 equals A plus 21 minus 1 is 20, 20D. And these are, once again, two equations that have two unknown variables. So I can use substitution or elimination. The way it's set up right now, I'm going to use elimination because my A's are ready to eliminate. Okay, so I'm going to subtract these because that's how I eliminate the A's. Okay, I like to subtract this way. I can choose the way I subtract as long as I stay consistent. 142 minus 72 is 70. 20D minus 10D is 10D. So 7 equals D. I can plug that into any equation up here. I'm gonna choose the one with the smaller numbers. So subbing into the 72 equals, that's not an equal sign, equals A plus 7 times 10. Bring the 70 over, 72 minus 70 is A, so 2 is A. Okay, so the first value of the term is 2, and they're increasing by 7 every single term. Start at 2, plus 7, plus 7, plus 7. When you hit the 11th term, you'll be at 72. When you hit the 21st term, you'll be at 142. Okay, and that's pretty much it for arithmetic